the Matlab GUI and Slurm in more detail. And something has been mentioned by Birgitte already. So we will understand here the concept of a Slurm scheduler. And also we will see how to start the batch jobs from the Matlab graphical user interface that we will call here a GUI. And we will try some examples. These are the projects for our different clusters, and here there are some folders that you have most likely used during this course. There are some warnings when using Matlab, right? So here, as it says, any longer source intensive or parallel job must be run through a batch script and not just by uh, using the button run on Matlab, right? And the login nodes in Matlab must be started with the option dash single com thread because otherwise Matlab will consume all the resources that it founds, yeah, and especially for the login node, you don't want to interfere with the workflow of the other users. And that's why you must start Matlab on the login node with this flag here. So Matlab is a relatively old software, right? And because of that, it has been coupled well to different job schedulers. And here in the Swedish clusters, we use Slurm as a job scheduler. And because Matlab has a good integration with the Slurm, you will see, or you have already seen that there are several manners to submit jobs to the queue, right? That are provided by Matlab. So you can choose what passes better to your workflow. One of them was already mentioned by Birgitte, is by creating a batch file, right? That you can use to submit the jobs to the queue. And here you will use the sbatch command and then the name of the file, right? So this is especially convenient if you don't need to interact a lot with the code. For instance, if you don't want to plot any figures during the running time of your code, and you only need the data that you can analyze afterwards. Another way to submit jobs to the queue is by using the batch command, which is an implementation of the sbatch command from Slurm, but that can be used in the Matlab GUI directly. And this will allow you for more interactivity, because in this way, if you know what function or what file is the one that will be executed in the queue, then you can submit that at the time that you want the results, right? So this allows you for more interactivity with the results so that you can, for instance, make some plots and see how the data is behaving, for instance, or analyze some data or time series. The third way to submit jobs in Matlab, and this allows you for even more interactivity. And this is by starting the so-called parpool. That is a function that you can start in the Matlab GUI. And here you can even change the code that you want to to submit the job to submit to the queue, and you can do that especially, and it's very convenient if you are in the phase of development, right? So there are several ways, as you can see here, and there could be even more options. So this is a Matlab graphical user interface, and Birgitte has shown you how to write a batch script. In this case, it's called my batch script, which is submitted to the queue with sbatch. But you can also submit the jobs here through the Matlab GUI. And in particular here, if in this part of the graphical user interface, in the editor part, you write a file or a script that looks like this, right? You create first a handler to the cluster, and here you choose the name of your cluster. For instance, at HPC2N is called Kebnekaise, and there should be an equivalent to the other clusters at UPPMAX or Cosmos, right? So you choose the name of the cluster, and you need to do the settings that were mentioned in the previous section, right? So that you can use the cluster in this way. So this will give you a handler, right, that you can use to submit the functions you're interested in, and that can run in the queue. Here you get the handler and use a method from the handler that is called batch, and this is the equivalent to the sbatch command mentioned above, but this is well integrated with Matlab. So here you pass either the name of a function, as in this case, or you can even pass the name of a file, as it was mentioned by Birgitte. So this function here, a batch, accepts as arguments the number of output values and also a list of the input arguments. So if your function, in this case, my function, accepts some input arguments here, you write them as a list. This is a string that should be there, pool, and here you write some number of workers that will execute the job. And this is especially important if your job requires some workers, or if your job runs in parallel mode by using some number of workers. So if you want to wait for the results and you don't want to continue with the Matlab, right? So you can use the command wait. And then when the results, the job finishes, then you can fetch the outputs, and this was done already by Birgitte. So the batch commands also accept script names, not only functions, and it's very convenient if you want to execute an entire file, for instance. In this case, if you pass a file name, then you need to take care of how your data will be stored. So it's more convenient to write a function, because in this way you know what the outputs are, and then when you fetch the outputs, you will get a list of the outputs in this command j.fetch outputs. So the first example that I will show you is for serial jobs, right? And here we assume that we have a file called host nm.m, and this file contains a single function, as it is mentioned here. Yeah. Then we start the park cluster with the cpark cluster function. We create a handler, then we submit the job to the queue with a batch job, and then we wait for the results. And when the simulations are done, when we fetch the outputs and get the outputs in this variable t. And finally, we print out the outputs, which is in this case is just the name of the host where the job was executed. So this is for a serial job. As you can see here, the number of workers is one only. And we can also have parallel jobs in MATLAB, and there are several functionalities for parallelizing a code in MATLAB. And here I will mention only three of them, but there are even more, but they are more specific, I would say. So I like to work with the par4, and then I also like this SPMD, and par-Fival is not that common, but it's also very useful depending on your needs. So par4, this is the first one, and I like this one because many research codes contain heavy loops, and this is a good option to parallelize these heavy loops, and then you can immediately see and speed up in your simulations. So, but for par4, there are some restrictions that are applied to the for loop. And here I wrote some of them, yes, three of them only, but there could be more than that. So first of all, the number of iterations must be well defined, meaning that, for instance, if you have a loop starting from, as is depicted here, from 1 to 4, so you cannot change this end and beginning and end of the loop. So it should be fixed. Also, you don't have control over which worker is executing in a specific task. So any worker can execute any task at any time, right? And because of that, the calculations that are performed in the for loop must not have any dependencies between the iterations. So all the data dependencies should be avoided inside a loop. So these are some restrictions that should be satisfied in order to use the par4. Otherwise, you will not get a correct results. It will be just some data that is not reliable. So for instance, in this particular case, we have a par4 that goes from 1 to 4, and it just display the name of the host, right? So here you can write even more complicated task, but this is just an example. The single way to parallelize a program in MATLAB is by using the serial program multiple data, SPMD. And here you enclose the code that you want to parallelize between these two keywords, SPMD, and then it finalizes with the end keyword, right? So here, what you write here inside will be parallelized by means of some indexes, and in MATLAB they are called label index to distinguish the different workers that you have. And you can then use this label index to partition, for instance, the workload. And in this way, you can parallelize your code. This requires a more elaborated code, and you will need to rethink the way that you wrote your code. For instance, in the case of a loop, you will need to define the specific range for a specific worker, and this can be done with the help of the lab index variable in Matlab. So this is more elaborated and also more specific. In the third mechanism that Matlab provides you to parallelize the code, we have this parfeval function, and I would say that this is more advanced. It's not that common as the two previous one, right? And the advantage is that here you can do asynchronous calculations, which means that you can generate several instances of a function, for instance, that are not executed at the same time. So in this case, for instance, with par4, you're trying to execute the code inside the par4 loop simultaneously. But here in parfeval, this is not required. So the computations can be done, for instance, when the resources, the cores are free to start running the calculations. And when you want to be sure that everything finishes, then you can fetch the results. And at this point, a barrier, a kind of barrier will be created where you will wait until all the processes are finished. So this can help you, for instance, if you want to perform a task that takes a different time to be completed, and this is especially good for this. But this is, I would say, is more specific. So here I show you how to run the parallel jobs containing these strings that I mentioned before, par4, spmd, parfeval. And in Matlab, there are some ways to run these codes, yes, that contain these functions. And I will mention some of them. How to run the code that contains the three instructions that I mentioned previously. So the first one is using batch, that is the function provided by in the Matlab and Matlab GUI. And here we assume that we have a file called hostnm.m, for instance, and this file contains a function with the same name in this case. And inside, we are performing a loop, but because it contains the word par4, it will be executed by some number of workers. Yeah? And because all the workers work independently, they need some way to store the data that they generate. And that's why here I created an external array. And here you need to store the data, which otherwise it will be deleted once the function finishes. You won't have a record of this stored data. So how to run this function here? So first of all, you create a handler to the cluster, and here you choose the name of your cluster. In particular for Kebnekaise is Kebnekaise. Then once you have the handler, you can submit the job to the batch queue with the batch function. This is the name of the function. Here is the number of outputs that you will have. In this case, is 1 because I will retrieve the output from the collective array. Here you write the list of arguments that in this case is just one because I have just one input argument, which is the number of iterations. This word here should be there is pool. And here you write the number of workers that you want. I will wait for the results and finally fetch the outputs and print the results. So this is when you want to use the batch command that is provided by Matlab, and it's well integrated with the S batch from Slurm. But as I mentioned before, there is a command or a function in Matlab called parpool that allows you for more interactivity. And in this way, the code that you execute inside a parallel pool will be executed on the cluster computing nodes, right? Only if the code contains the strings or the functions parpool, par4, spmd, and parfeval. Yeah, only if it contains par4, spmd, and parfeval, sorry. And everything else will be executed on the login node. If you are in the login node, for instance, starting your MATLAB session. So you need to be aware of this because maybe inside the part pool that you are opening, so you have a very expensive serial operation which doesn't contain any of these functions, right? And then you have one that contains this function. In this case, only the function that contain par4, spmd, parfeval will be sent to the parpool computing nodes. The rest will be executed locally. So in the following example, we have a parpool of n workers, yeah? And this is used to solve a par-for loop. So this is how it works. First, we create a parpool. And here you write the name of your cluster, for instance, Kebnekaise, and you specify the number of workers, in this case, given by the variable n. And then once you start the parpool, you can start some parallel code that contains, as I mentioned before, the par4, spmd, parfeval, or even there are other functions that I didn't mention here. For instance, parsing that will be executed on the cluster computing nodes. And what I mentioned before is that if besides this par4, you have here a here or here a function that doesn't contain these strings, they will be run on the login node. And that could cause some problems to the other users that are in the login node at that time. You shouldn't, you must not do it. Yeah. So once you are done with the parallel pool, you just delete the parallel pool with this command here. And after that, no pool will be available. And then at this point, you can think on the serial code that can be run on your local machine, for instance. Okay, is there any questions at this point? Okay, so I can continue in this way to the next session. Is that okay from your side?